Hello, hello, hello. Let's go and talk about special type of factoring. So we have few of these. There should be special types of factoring, but start with the wrong title. There we go. Perfect. So we have been talking about factoring in chapter 6. After this section we have one more and we are ready for exam 3. So what we are going to do now is take a look at the special types of factoring. Next class we are going to actually do a mini review of multiplication and factoring to see how those are, inverses of each other and opposites of each other and so on. But that's next class. Now we want to learn special factoring, and that's actually going to be those two formulas you learned last class for special products. So the formula you learned last time said a plus b times a minus b is a squared minus b squared. Factoring version will be called difference of squares, and it's the same formula, it's just read the other way. So I hope you see the word difference, right, and the word squares, right? So difference of squares. So if you have two values that are squared, while in a difference, you can use this formula. So this is our formula, the first formula that we are dealing with today. And again, this is something that you either memorized and you know, or you don't. It's very simple. There is nothing you can make up here. And there are no crazy calculations either. An example. X squared minus 100. Right? So, what do I see? It has two terms. It has a difference. And both of these are perfect squares. Right? So it has all of the features, and all I need to do is to write that this is x plus 10, x minus 10. Because square root of x squared, right, is x. If you take a look here, you see that this is a and this is a. This a has a square, well this x has a square, so you write one without that square. It's that simple, right? It's that simple. B squared, not negative b squared. B squared is 100. Well, if b squared is 100, then b better be 10, because when I square b, I get b squared, and when I square 10, I get 100. So, these are the things that we just know. There is no computation. It is visually, right? You match them. Say you have x squared minus 36. Well, that's x minus 6. Of course, x plus, it doesn't matter which one you put first, but to be consistent with the formula up there. You can put minus or plus first, it doesn't really matter. Y minus 196. Y squared. That's y plus 14, y minus 14. Go ahead, take a square root of 196 in a calculator. You will get 14. So all we need to do, right, in this mess here, is to take a look at the square roots of these two values. But you have to be careful. If you have a plus, right, if you have a plus, cannot factor over real numbers. Some people say can't be factored, some people say undefined, that's all wrong. We can factor this with complex numbers, and we will factor this in intermediate algebra, pre-calculus, calculus, differential equations, right? Later math, we factor this, it's okay. For elementary algebra, we do not factor this one. Why? Has a plus. It's very important to learn the red formula, and the title says difference, right? This is sum of squares, so it doesn't fit our formula. So we have, right, it's a plus. So that's the first thing. Now, a little bit spicier examples would be maybe 4x squared minus 9y squared. Do we have difference of squares there? Well, yeah, right? See, square root of 4 is 2, and then we have x. And then we have square root of 9 is 3, and then we have y. And you just repeat the same one with a minus. If you don't believe me, just check. Foil. Right? So that goes there, that goes there. So what do we get? We get 2 times 2, that's a 4x squared, minus 6xy plus 6xy, and then minus 9y squared, and these two cancel. And there's your 4x squared minus 9y squared. What else do we have? We have an expression, factor trinomials. Let's see some of the book problems. Here is one from the textbook. It says 100 minus 16t squared. Again, 2 subtracted perfect squares. So how everything works. They don't have to be perfect squares, but it's easier, it's nicer if they are. So 10 plus 4t, 10 minus 4t. Right? Square root of 100 is a 10. Square root of 16 is 4. And then you have t squared becomes a t. Repeat the same one. Right? Repeat the same one with a minus sign. What else? Well, actually, that's it. I mean, there is not much that we can do here. This is, you either learn the formula and you are able to do it in one step. There are no calculations, right? Or you didn't learn the formula and you can't do it. It's very simple. So you can't make this stuff up. So it's called difference of squares. And now we have our next set of formulas, which is called perfect square trinomials. And those are the other two. So if you have a squared plus 2ab plus b squared. That condenses into a plus b squared. And if you have a squared minus 2ab plus b squared, that's a minus b squared. Okay. This one is trickier, still doable. So let's say you have x squared plus 18x plus 81. Well, what we first notice is that we have perfect squares on two of these. And the middle one might or might not match. If it matches, you can factor it using this method. If it doesn't match, then you can't. Now, what do I mean match? Well, that one has to be 2ab. And you have to check that every time. It's very hard to spot the correct form immediately, especially when you are seeing this stuff for the first time. You know, easy for me, you know, because I'm dealing with this for decades now, decades, right? I learned this when? I don't know. 8th grade, maybe? Maybe 7th? I don't know. I don't remember. So it's been decades. And I've been using it since. And I know it very well. So it's easy for me to spot it. So the way I do this is I first make sure that these are perfect squares. And then I solve it in my head. And then I check the middle term. So this is what the way I do it. Square root of the first, that's just x. Sine of the second, which is a plus. And square root of the third, which is 9. And you put a square. And then you check the middle term. 2 times x times 9 is equal to 18x. It matches, so this is good. Right? It is very simple, but this must be done. Must be done. Here is the example why. X squared plus 20x plus 25. If you go and you write x plus 5 squared, that would be wrong. It's wrong because 2 times x times 5 is 10x, not 20x. So this problem cannot be factored this way. My tablet is overheating because I just had a 2-hour class, and it's making it's going to start giving me issues and problems now. Great, my pen stopped working. I just have to find the other pen. It's frozen. Yeah, it overheated. Tablet overheated. Okay, I hope that this is now back running. My tablet is overheating because it's been working constantly for 2.5 hours streaming, and it's just all right. So it's tough. So it cannot be factored this way. It cannot be factored. This problem cannot be factored this way. Even though these are perfect squares, right? These two are perfect squares. They're still, even though they're perfect squares, it's still not this type of factoring because the middle term didn't match. So if you are writing some kind of a steps for a squared plus minus 2ab plus b squared, it goes like this. Square root of the first, sine of the second, square root of the third, number 4, this is the most important. Check the middle term. Let's do it. So you absolutely must check the middle term, otherwise there are issues. So x squared plus 14x plus 49. I know it's a special type of factoring because there is a square, there are square terms here, right? But I don't know if it is until I check the middle term. So my suspicion is, so square root of the first, that's x. Sine of the second, that's a plus. Square root of the third, that's a 7. And now we check the middle term. 2 times x times 7 is 14x, so we're good to go. So that's how it goes in this case. Let's go and do more examples. Say you have x squared minus 10x plus 25. Okay, I have perfect squares. My suspicion is that this is going to be this type of factoring. So square root of the first, sine of the second, this is the second term, right? Maybe I should add the word term in this one over there. So sine of the second, and then square root of the third, and we put a square. And now we check the middle term. So I have 2 times x times negative 5, works out to be negative 10x. That checks to be negative 10x, so this is good. You have to do this, because if this doesn't match that, then that will be wrong. Remember, right? We had the example where it didn't match, so this was wrong. And you see that at the 20x, I still have my x squared and 25. That had to be 10. See? 10. But it was not 10. So this was wrong. Right? That answer was wrong. You have to check this middle term, otherwise the problems that look like they're there, but they're not, are going to give you issues. Let's try 9y squared minus 18y plus 4. Square root of 9 is 3, y. Square root of 9 is 3, and then y, right? Sine of the second is a minus. Square root of the third is a 2. Squared. And then we check the middle term. That's 2 times 3y times negative 2. 2 times 3 is 6. Times 2 is negative 12y. Not the same as negative 18y, so this is wrong. Cannot factor. Wow, the tablet is really struggling. Using this method. I have to find a way how to keep the tablet cool. Let's take a look at few homework exercises regarding this special. There are some spicier examples that we can work with. Let's hope the tablet keeps it together here. 9x squared plus 30x plus 25. Okay, square root of the first, 3x. Sine of the second, plus. Square root of 25 is 5. Everything squared. Check the middle term. 2 times 3x times 5. That's 6 times 5, 30x. Do I have 30x? Yes. Good. You have to do this check, and then you have the problem. Let's see another one. Let's take a look some of these more complicated cases, like x squared minus 6xy plus 9y squared. Alright, so square root of the first is x, sine of the second is a minus, square root of the third one is 3y. Put everything squared. Square root of the 9 is 3, and then you have y squared, so take away a square, it's just 3y. Sine was negative on a second term, so we have a negative there. If you take a look at the formulas that I gave you earlier, positive and negative correspond to positive and negative in the factored answer. So make sure you have that. Alright, cool. So, check the middle term, and what do we get? We get, you just multiply these guys, so 2 times x times negative 3y, because those are your a and b, right? So just multiply those two, because you are recreating 2ab, which is the middle term. Is this good? Yeah, that's negative 6xy. Good to go. Here's another example. 25x squared plus 60x plus 36. Oh, sorry, minus 36. Minus 36. Cannot factor here. Wow, the tablet is going crazy every time when I get an example that can't be done. If you really go back in the video, you will find that every time the tablet was blinking and going crazy was on the problem that cannot be done by this method. Why cannot be done? Cannot factor using this method. Wow, it's terrible. Cannot factor using this method. Why? Because it doesn't match the formulas. You must memorize the formulas. If you don't memorize the formulas, then you have no chance in doing any of this. And the formulas, what do they all have? They all have a positive here. This is a plus. Now, if we go and take a look at our formulas, what do we see? It's always plus b squared, right? It's always plus b squared. So you have to make sure that the problem you have is matching the form of special factoring. If that doesn't work, then you have to use other methods of factoring. There are other methods. A lot of other methods. We are going to even learn another method at the end of end of the course. Now, we'll do one more of these examples, and then I guess shut down before this thing explodes or something. 25 y squared minus 20yz plus 4z squared. So we see perfect squares on both ends, so let's try. That's 5y, square root of 25 is 5, and then we have a y. Sign of the second term is the negative. The third one has a positive, so we can go ahead with the method. Square root of 4 is 2, and then we have a z, and put everything squared. And now check the middle term. We have 2 times 5y times negative 2z, and that's going to give us negative 20yz. Does that match? Yes, it does. Good. So you have to be very careful with this type of factoring. You have to learn the formulas well, and then you have to first make sure that that's always a plus. Otherwise, it doesn't work, because in formulas, that's always the plus. So you make sure that's a plus first. Then also these need to be perfect squares. I mean, they don't have to be, but in this class they are. And if these are perfect squares and this is a plus, then you can use the assistant square root of the first, sine of the second, square root of the third, everything's squared. And then you must check to make sure that the middle term matches. So you take your a, you take your b, you put your a, you put your b, 2ab, and that has to match what you have over there. Now, there is one more type of factoring here that is given to us. I am going to write it out, and I have to check if this one is the part of elementary or intermediate. Used to be in intermediate only with cubes, but it might be now pushed back in elementary as well. So I will check on this one, but I'll write the formulas just in case, so we have everything. A cubed plus b cubed is equal to a plus b, a squared, change the sign, ab plus b squared. There's no 2 now. And a cubed minus b cubed is a minus b, a squared, change the sign to plus, and then plus b squared. So these are sum and difference of 2 cubes. And you see that this part here is very close to what we had before. There's no 2 in front now. Another thing that you can easily remember is, this is the way I learned it, is, see the plus there? So I say keep the sign, change the sign, always plus. Keep the sign, change the sign, always plus. See, keep the sign, change the sign, always plus. Keep the sign, change the sign, always plus. That's how I remembered. I don't know why, but keep the sign, change the sign, always plus. So keep the sign, change the sign, always plus. That's how I remembered it. So what we have here is, let's say you have x to the 3 plus 27. Now this is a little bit harder, but this one over here is 3 times 3 times 3. So we have x, keep the sign, plus 3. And we have x squared, change the sign. And then we have a times b, that's 3x, plus b squared, which is 3, so 9. Again, this is a little bit harder to deal with, and I will check if this is still the part of elementary algebra. Let's say you have 8y cubed minus 125. We memorize these 5 or 6 numbers. For cubes, we have a positive and a negative formula, so yes, we can factor. We have a formula for the negative, so we are going to use the formula for negative. Okay, so 8 is 2 times 2 times 2, and 125 is 5 times 5 times 5. So we have 2y minus 5 because we keep the sign. Then we square a, so this is your a and b now, right? So when you get this one, you can now square, that gets a 4y squared, that's your a squared. Change the sign, so it's a plus now. A times b is going to be 10y, because that's ab. Always plus at the end. B squared is 25. So we quickly find that a is 2y and b is 5, right? That's crucial. And then you just keep plugging them in where they belong in the formula, because you know a, b, a squared, b squared, and so on. Let's do one more example of this, because these cubes could be issue. I'm going to go to the homework and find something that it's given. So they say, problem 68 says 27x cubed plus 64y cubed. So we can factor this whether it's a plus or a minus because I see the question in chat, right? For the cubes, we have both formulas. We have a plus formula and the minus formula. For these guys, we also have plus and minus formula. And finally, this one is the only minus, right? It's the only minus formula. All right, let's go back all the way down. All right, so what do? Well, first thing I say, What's the cube root of 27? That's 3 times 3 times 3 gives 27. So A is 3x. And for 64 is 4 times 4 times 4 is 64. So B is 4y. So now I have keep the sign, so that's A plus B over here. So that's 3x plus 4y, because I know what my A and B are already. And parenthesis says A plus B, right? Then I have A squared. Well, that's 9x squared, because 3 times 3 is 9 and x squared, right? And then change the sign, so minus. And now we need AB. Well, just multiply these two, you get 12xy. Because A times B, 3 times 4 is 12xy. And the last one is always plus B squared, that's 16y squared. $16y squared. So memorizing the formulas is crucial for this section, and using them when it's appropriate. So next class, which is on Wednesday, right? No, sorry, tomorrow. So the next class, which is tomorrow, I'm doing, I explained this last time or time before this one, right? I'm doing every day a short lecture rather than 2 lectures per day, twice a week. I do 1 short lecture 4 times a week rather than 2 lectures, right, 2 times a week. So you still have the same amount of material, it's just easier when you do little by little. So tomorrow I'll be on at 3, then on Wednesday I'll be back at 1. So I go 1, 3, 1, 3 as I go through the week for this with these streams. All right. So to summarize everything, we have factoring number 1, which is a squared minus b squared, and that's a plus b, a minus b, called difference of squares. Then we have the second type of a factoring, which is a squared plus ab plus b squared is a plus b squared, or a squared minus a, 2, so I forgot the 2 there, plus b squared is a minus b squared. And finally 3 for the cubes, a cubed plus b cubed is a plus b, a squared minus ab plus b squared, and a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. So keep the sign, change the sign, always plus. Keep the sign, change the sign, always plus. So these are all of the formulas, right, in one spot from today's class on the special factoring. All right. So regarding exams, since my MATLAB had a lot of issues and so on, I am almost done with getting the exams to work in Canvas, so all of you can access. And exams are supposed to be in Canvas from now on, so we don't have issues like last time where half of you couldn't even open the exam, right, at all. So we are going to have exam 3. So we are a little bit behind for exam 2. So I'm going to work something out for exam 2, but we need to focus on exam 3. So I'll just write here exam 3 is chapters 5 and 6. Now, the idea is, so Monday, which is today, we did 6.4. On Tuesday, we're going to have multiplication versus factoring overview. Then Wednesday, we're going to learn 6.6. And on Thursday, we're going to have exam 3 review. And then exam 3 next week. I don't know, let's say Thursday through Saturday. And I'm planning to put it on Canvas. So this is all exam 3 stuff. Chapters 5 and 6. Monday is 6.4. So let me say learn 6. Learn 6.4. That was today, right? Then on Wednesday we're going to learn 6.6. I think it's next one is 6.6. Yes, and that's it. So we'll have to put a lot more practice. Afterwards, we have chapter 7 and a section in chapter 10. We have to start practicing after that like maniacs for that upcoming final exam, right? So we don't have a lot of material left. So this week we are going to finish chapter 6. Next week we will be practicing and having chapter 3 exam. Following week, so yeah, this week, this exam, the following week we are going to deal with the new material for chapter 7 and 10. It's only 4 sections, 4 days. That's good. And then the first week of May, we're just going to practice a lot, take exam 4 and practice a lot for the final. The next week is the final. And then the following week, guys, summer 1 starts. So, yeah, we're a little bit, we are on time. We don't have to, we are not behind or anything, for both classes. So we're just go slow, right? From here, make sure that we are, covering all the concepts, and we will be okay for it. So I'm going to open chapter 6 homework. And I will see you all tomorrow in a very important section where we are going to discuss the factoring and multiplication and see that they're, backwards one from another, where we, multiply one way, we factor another way. So I'm opening all of chapter 6 now, whatever I missed. So 6.1, 6.2, and 6.4 will be available for a week. I hope you guys will be logging in every day to do, at least some of the problems, so you are not behind. So I'm going to close this on the 20th. So make sure that you solve all of these sections by the 20th of April. And I'll be back tomorrow at 3. So that's Tuesday. Yeah. So Tuesday I'll be back tomorrow at 3 to finish off. Well, not to finish off. Tomorrow we'll do a lot of problems for multiplication and factoring, just to make sure we have them all put together. So homework is open. Please go do some problems, and then tomorrow we'll have that overview. Bye.